In this video, we are going to learn how to solve these JAMB Physics repeated questions under Lenz law and transformers in electromagnetic induction. So we are going to practice with 20 repeated questions for these subtopics in electromagnetic induction. So let's get started. The first one I have here says, which of the following devices may be used to step up the voltage in DC circuit? We have a step-up transformer, we have a DC generator, we have a watt meter, and induction coil. So the right option to this question is option A, which is a step-up transformer. Okay, so that's the answer. The next repeated question will be this one. It says a core of an efficient transformer should consist of laminated pieces of metal in order to increase the heat produced by increasing the AC current, reduce the heat produced by increasing the AC current, reduce the heat produced by reducing the AC current, increase the heat produced by reducing the AC current. So the right option to this question will be option C, which is reduce the heat produced by reducing the AC current. That's the right option. The next repeated question will be this one. It says the diagram above is that of, so we have option A, an auto transformer, a step down transformer, an oil transformer, a step up transformer. So the right option to this question is option D, which is a step up transformer. Alright, take note of this particular question, guys. The next repeated question will be this one. It says a step down transformer is used on a 2.2 kV line to deliver 110 volts. How many turns are on the primary readings if the secondary has 25 turns? Okay, now guys, for questions like this is basically the formula to apply to solve this kind of problems. So this is the formula I use this formula: NP over NX equals VP over VS, where the NP is the number of the primary turns, the NS is the number of secondary turns, whereas the VP is the primary voltage, the VS is secondary voltage. Alright, so for this question, we asked how many turns are on the primary readings. Okay, so looking for the primary turns, the number of primary turns. So we are looking for NP, that's just for X equals, our NX is, if the secondary has 25 turns, 25 equals, now our VP is 2.2 kilovolts. So convert 2.2 kilovolts to volts should be 2.2 times 1000. This will give you 2200 volts. So we have 2200 volts over, now our secondary voltage is 110. Okay, so when you cross multiply, you're going to have 110x equals, alright, so let's get the JAMB calculator. It's going to give us 110x equals now 2200 times 25. Okay, so we have the output to be this. So we have 55,000. Divide both sides by 110. This will cancel this. So our X will be this output divided by 110. So we have it to be about 500. So the right option is option A. Okay, so it's as simple as this. Let's wipe this and solve the next repeated question. So the question says a transformer is rated 240 volts if the primary coil is 4000 turns and the secondary voltage 12 volts. That means the number of turns in the secondary coil. So we are still going to make use of this formula. Our NP over NX equals VP over VX. So in this question, our NP will be 4000 turns over, we are looking for the NX equals, our primary voltage is 240, our secondary voltage is 12. When we cross multiply, so basically we are going to have 4000 times 12. That will give you 48,000. Alright, so you're going to have 48,000 equals 240x. Divide both sides by 240. This is 240. So this we can see self. So our x will now be 48,000 divided by 240. So we have 200 tons. That's the value of the NS. Okay, so it's as simple as this. Let's write this now. So the next video question. Okay, so the next video question will be this one. It says, which of the following describes the direction of an induced EMF? We have Faraday's law, Coulomb's law, Ohm's law, Lenz law. The right option is option D, which is what Lenz law. The next video question will be this one. It says, which of the following principles or laws that means the direction of an induced current in a conducting loop of wire due to a changing magnetic flux? We have Faraday's law, we have Biot-Savart's law, Gauge's law, Lenz law. The answer is still option D, Lenz law. Okay, the next question will be this one. It says the primary winding of a transformer has 400 tons and its secondary has 100 tons. If the source of EMF of 12 volts is applied to the primary, the secondary EMF will be okay. So let's still make use of our MP over NX equals VP over VX. So in this question we have the primary turns to be 400 over secondary turn is 100 equals, we have the primary voltage to be 12 volts over, looking for the secondary, cross multiply, going to have 400x equals, now 100 times 12 give you 1200, divide both side by 400. So we'll be left with 3 volts. So that will be the answer to this question, option C. Let's verify this. 1200 divided by 400. That should give you 3. Yeah, correct. So the right option is option C. It's as simple as this. Let's wipe this now, solve the next repeated question. So the next repeated question will be this question. It says, which of the following devices in their common form will not function on a steady direct current? We have transformer, we have electric heating element, we have filament lamp, we have electric bulb. So the right option is option A, which is transformer. The next repeated question will be this one. It says the wasted energy due to reversing the magnetization of the core of a transformer is called, we have hysteresis laws, eddy current laws, leakage of magnetic laws, I square R laws. So the right option is option A, which is hysteresis laws. The next question will be this one. Guys, take note of this particular question. The next one will be this one. It says, which of the following physical laws is the basis of Lenz's law? Now, guys, before we attempt this question, if you are new to the channel, ensure that you are subscribed to this channel for more of our videos. We really appreciate this, guys. So we have option A, Newton's third law, conservation of energy, Newton's first law, Gauge's law. So right option this question is option B, which is conservation of energy. All right, the physical law here that is the basis of Lenz's law is conservation of energy. The next question will be this one. It says, which of the following statements are true according to Lenz's law? We have Lenz's law gives the direction of the induced current or EMF. That's correct. Lenz's law is a law of conservation of energy. That's correct. Lenz's law contradicts the law of conservation of energy. This is wrong. So the right option is I and II, which is option D here. I and II only. Okay. Next question will be this one. It says the main purpose of a transformer in an AC radio set is to have step down the voltage, step up the voltage, convert energy from AC to DC, increase power to the radio. The right option in this question is option A, which is to step down the voltage. Next question will be this one. It says Lenz's law is a law of the conservation law. So this is obvious. Option A is the right one. It's the conservation of energy. Next question will be this one. It says the primary winding of a transformer has 400 tons and its secondary has 100 tons. If the source of EMF is 12 volts is applied to the primary, the secondary EMF will be, so guys, this question should be very, very simple to you now. So we have our MP over NS equals VP over VX. This is B, guys. So we have our MP is 400 over 100 equals Our VP is 12. We're looking for Vx. When we cross multiply, we're going to have 400x equals, so 1000. 100 times 12 give 1200. So you see, I think we have solved this question before. When you divide both sides by 400, our x will be 3 volts. So the secondary voltage is 3 volts. Option C is the right option to this question. Okay, it's as simple as this. Let's wipe this now, solve the next repeated question. So the next repeated question will be this one. It says a transformer has 800 tons of wire in primary coil and 200 tons in the secondary coil. If the input voltage is 600 volts, the output voltage is, okay, so you still apply NP over NX equals VP over VS. So guys, you should note by now that this formula is very important. So this will give us our NP will be 800 over 200 equals our VP is 600 over X. I'm looking for the Vx. Okay, cross multiply, we're going to have 800x equals, now 600 times this 200 you have here. Basically, we are going to have this output. So we have 120,000. So you divide both sides by 800. Okay, so 1200 divided by 8. Let's check on this JAMB calculator. 1200 divided by 8. So we have the output to be 150. The right option is option C. Okay, 150 volt is the secondary voltage. So let's wipe this and solve the next repeated question. So the next repeated question will be this one. It says the electromagnetic force in secondary winding is, we are varying, increasing, reducing, stabilizing. The right option is option B, which is increasing. Take note of this particular question as well, guys. Okay, next repeated question will be this one. So it says energy loss due to AC current can be reduced by, we have using thick wires, the use of special alloy, using thin wire, laminating the core. So this is a simple question. The right option will be option D, which is laminating the core. So the last question before we end this class will be this one. It says if the mains supply voltage of a transformer is 200 volts with primary current of 30 ampere, calculate the output current of the transformer if the output voltage is 150 volts. Okay, so now take note, the formula we're going to apply now will somehow be in a reverse form than the ones we have been using to solve all these questions, calculative questions we have encountered in this video. For this particular one, this question does not involve number of turns, rather it involves voltage and current. So the formula to apply will be secondary voltage over primary voltage equals primary current over secondary current. Okay, so from this question, our secondary voltage is 450, our primary voltage is 200 equals, we are looking for, so we have a primary current to be 30, we're looking for the secondary current. So when we cross multiply, we're going to have 450x equals, so 200 times 30, you're going to have 9,000. Okay, so sorry, this will give you 6,000, not 9,000. Alright, divide both sides by 450. So our x will be 6,000 divide 450. So we have it to be what? 13.33. The right option is option C, ampere. 13.33 ampere. So guys, this is how you can basically do problems involving Lenz law and transformers in electromagnetic induction. For the JAMB Physics, we practice with 20 repeated questions for this topic. Hope you learned something interesting from the video. Let's go to the video, guys. If you are new to the channel, once more, ensure that you subscribe to this channel for more of our videos. Also like, share, and comment on this video. Tell me how you feel for what I learned from this video. If you seem to have any specific question to ask regarding what I've talked about in this video, feel free to leave your question in the comment section below and I'll ensure to give you a response. Also ensure that you're part of the channel membership and click on the join button where you'll be receiving special information that will help to simplify your academic work. So having done that, click on the screen above and I will see you in the next video. Thanks for watching.